interior, and we're going to continue working on that. But when you adopt a float, you're given a choice of which program you want to use. We also decided to have a sticker contest this year, and we got some amazing contributions, some amazing submissions for the stickers. And you can see some of them here, beautiful, beautiful stickers. The winning sticker was drawn by Kaylee at McDougall School in Chapel Hill, North Carolina. We liked it so much, we decided to use it for both programs, GO-BGC and SOCOM. And so we do now have some stickers available that we could ship out when you adopt a float. We'll send you some stickers too, just so you could use some of them with your students. And thanks to Dirk Slowinski, we're also starting to build some Lego floats. And these are the Apex, patterned after the Apex model. And I've been furiously building Lego floats. I think I have 50 of them built now. And we'll use these for outreach, as well as these beautiful education floats you could see in the right-hand picture. So these are were put together by Hans Janisch, who recently retired from MBARI. And these education floats are encased in a see-through housing so that you can see all the components of the float. And the floats are actually composed of real components, real sensors, just ones that are not working anymore. So we've gotten contributions, we've gotten donations from different sensor manufacturers, and we've been able to put these floats together. The only thing that's not real in the floats are the batteries, because putting real batteries in there didn't seem like a good idea for weight reasons, safety reasons, and because there's nothing in there that's going to work. So instead we have wooden dowels in there to simulate the batteries. We have these education floats available for use on the we'll have one on the East Coast and one on the West Coast. And Robert Key and myself and others have been taking these out to schools to let the students get an idea of what the floats really look like in terms of size, and what the sensors look like up on the top and what the float looks like on the inside. So these are a great contribution as well. We're also working on some lesson plans. Right now, the lesson plans that are on the website were mostly developed for the SOCOM project. So they're focused mostly on the Southern Ocean. We are starting to work on generating some specific lesson plans for GO-BGC for other ocean basins. And one of the people working with me on this is Emma Monson, a University of St. Thomas undergraduate student, who is also the first GO-BGC summer intern. And she's working with us virtually at MBARI. She's still back east at the University of St. Thomas, and she's starting to develop some of the templates that we'll be using for lesson plans. And she's also developing a social media outreach plan to try to help me get more floats adopted. So again, follow us on Twitter and keep an eye out for the social media campaign that Emma is in the process of developing right now. We also have a Makerspace program, and this is run by Todd Martz at Scripps. And last quarter, winter quarter, as he called it, the winter quarantine quarter of 2021, he had a graduate level class in marine chemistry, an instrumental lab, and he had students building all sorts of different sensors. And you can see some of the students here with the sensors that they built. Scripps will hopefully be opening up soon, and we'll be able to get the students into the Makerspace itself to get some more hands-on work. And this is a great way to increase the workforce by getting students actually making some sensors and learning what goes into making the sensors and adapting them for use in different areas. And then finally, I want to talk a little bit about the MATE program. For those of you who are unfamiliar with the MATE program, the Marine Advanced Technology and Education, this is one of our main outreach partners for GO-BGC. MATE has been running an ROV competition, remotely operated vehicle competition, for many years now, and they're continuing even this year. The national competition will be in August in Tennessee, if you happen to be in that area. But you could also tune in and watch it virtually, because they've built a virtual workspace, a virtual competition space, so you could participate and enjoy the students who are building remotely operated vehicles and competing with various tasks. This year, as a part of the MATE competition, they've set up a separate challenge specific for floats. And so what MATE will be doing for their outreach is integrating float-related science and technology into the more traditional MATE ROV competition scenario and tasks. So this year, it's a satellite challenge. In 2022, we'll start to add more challenges that are inspired by floats and sensor technology into the ROV competition and satellite challenges as well. So this year's challenge, which is now active, so if you know of any students that are interested in participating, you could still apply, is to build a device with active buoyancy, no thrusters or propellers, that could descend to depth and then ascend back to the surface, i.e. do a vertical profile. And the challenge, the winner, will be the person who completes the most vertical profiles in 10 minutes. So this is obvious technology that we're all familiar with now. This is a profiling float. It's inspired by the real world. And because of the pandemic, we're going to do it the real world way. Teams that are going to be involved in the challenge will ship their floats to the University of Washington, where engineers will complete a system check. And if the system checks out and everything's safe, they will launch the float into their test tank and then watch it profile. So the float has to arrive with a good battery voltage, with vacuum pressure, as well as full information to the University of Washington engineers on how to run a systems check, put the float to sleep, and how to activate the float to start its profile run. And then the specifications of the test tank itself, it's 4 meters deep. The float cannot be any taller than 1 meter, and it has to be less than 18 centimeters in width or diameter. It has to have an antenna, which will be non-operational. It doesn't have to work. Has to be held above the water line, at least 10 centimeters. And we're given 12 volts and a 5 amp maximum for the battery. And you have to be able to have a vacuum of 40 pounds per square inch. There is a video demonstration you have to provide just to show that the float actually works in addition to that. And then there's additional information with the challenge that talks about batteries and amperage and the buoyancy engine that can be used to power a float. And in the pictures, you could see the buoyancy engine that the Apex float uses. And as the final part of the operation checklist, you have to provide instructions on how to activate, deactivate, and talk to the float. And so if you do have questions, you could send them to me or you could send them to MATE. And Jill Zande, Rick Rupan, and Matt Gardner are the ones who came up with and are running this particular floats challenge activity. And with that, that's all I have. So I'm going to stop sharing and see if anybody has any questions. And if not, we could even start our breakout rooms a little bit early. And again, I don't see any questions in the chat, so I'm going to give up my presenting capability and let Todd and Mariah talk a little bit about the breakout sessions that are going to be coming up.
Thanks, George. So I'm not sure if was Andrea going to give a rundown of the breakouts or Mariah?
I think it was Alison.
Yeah, so
Alison.
hi, it's me, Alison. I am going to give a sort of a 15-minute overview that's for everyone, not language specific, on data access, and then we're going to go into breakout rooms. I think that's the plan. See if I can...
Your presenter now.
Okay, great. And everybody can hear me okay? Okay.
Yep, sounds good.
Great. Okay. You seeing my screen now?
No, not yet.
Yeah.
Okay, hold on. It's thinking really hard.
there settings?
Well, it just seems that like WebEx kind of froze for me, unfortunately. Let me.
I'm gonna send your slides to Roberta.
Looks like Alison froze.
Yeah. That's good.
And Mariah, I forgot to hit record.
Okay, I got it.
Thank you.
Thanks, Roberta.
While we're waiting, I can maybe just give a few reminders for after this overview talk that Alison's going to give, which is a bit of an intro to just what BGC Argo files look like. And so after this intro, we'll break out into the breakout rooms associated with the programming language of interest to you. And we'll have different leads going through the tutorials in those rooms for about an hour. But you'll notice, I think, George, can everybody see the breakout rooms at this point?
Doesn't look like it.
I can see the breakout.
Oh, okay.
Can you? Okay.
You
good.
can. Okay, yeah, I can see them. All right, so you'll notice there's the MATLAB one, a
I
Python
could see them as a
one.
co-host, but I can't see them as
Oh,
an attendee.
Oh, I see. Okay. Well,
Hi, Emily here. It says that the host is going to assign us.
okay. I think George will probably make it so that we can each select the room. But what I'll mention is that you'll want to go into, it'll say MATLAB tutoring, Python tutoring, or R tutoring. And within each room, you'll have a different instructor leading you through a demo. You'll also notice once the breakout rooms are made available that there are additional breakout rooms. So for example, one that says Python Help Session 1, Python Help Session 2. And those are just there in case anybody's having any technical difficulties. If you could just use Slack to inform, on Slack, there are channels that say, help desk R, help desk Python, help desk MATLAB. So if you're having trouble, please just use those channels, and other people who are assisting with the tutorial will be able to interact with you. And if necessary, you can go into a different breakout room like Python Help Session 2, and then speak face-to-face with somebody or share your screen if you're having like technical issues. So that's kind of the gist of how that will work. I think Alison's working on getting back on right now. Yeah, she had to restart her computer. She'll be back shortly.
George, do you know how I change the breakout sessions so people can pick their own?
Yeah, there should be a toggle. Maybe try closing them and restarting them and there should be a button to let people choose their own.
I'm able to select which breakout sessions. So there's a menu on the top, breakout sessions, and then join breakout sessions. So that's activated for me.
Yeah, it's activated for all the co-hosts, but not for the attendees.
Okay, hello. Hopefully people can hear me.
You're back.
Okay, I'm now the presenter. I apologize. Luckily, we had some extra time, so thank you, George. So we're not even late now, so. Okay, so I'm gonna attempt to share my screen again. How does that look?
Looks
Great.
good.
Okay, I think I'm back on track. Okay, so thank you all for your patience as I dealt with some technical difficulties. So my name is Alison Gray. I'm an assistant professor at the University of Washington. I am going to spend the next 15 minutes or so talking to everyone about a bit about data access, about how to begin to discover, obtain, and examine GO-BGC data, or BGC Argo in general data. This whole effort really, this data access tutorial was a very, it was a great group of people who put a lot of effort into this. And so I wanted to acknowledge members of the organizing committee, especially Andrea, Rue, Steve, and Yui, as well as all the people who really are working hard to put on this language-specific tutorials that we're going to break out into in about 15 minutes. Okay, and then especially thanks to the OCB, US CLIVAR for sponsoring the workshop, and then of course all the funding agencies for sponsoring this program. Okay, so the format, which I think maybe Andrea covered a little bit, but we're gonna, I'm just gonna talk briefly about language agnostic parts about getting started with float data. And then we'll break out into these hands-on tutorial sessions in breakout rooms and really give you a chance to practice selecting data, finding data, downloading it, and starting to look at some of the float data. Of course, in 60 minutes, we're only going to be able to kind of scratch the surface of what you can do, but hopefully this will be a good learning experience and you can get started. Okay, so please ask questions via Slack or the chat. And we also have help desk channels where you can get help either now or sort of later on too. We'll can continue the discussion after the workshop. I also want to kind of, before I say anything about data access or working with the data, I really want to encourage you to, if you haven't already, watch the pre-recorded talks from Tanya Maurer on data management, as well as Yui Takashida about data, about the sensors themselves, but also particularly for today's topic about how the different adjustments are made. Because we're going to be working with the adjusted data. So if you want to know what that means for each sensor, I really encourage you to look at Yui's talk and all the references that he's provided as part of that. Okay, so there's really, I'm going to say just 3 steps maybe to identify or to using GO-BGC data and to getting started. So the first step is discovery. So which floats do you want? What data do you want? What's out there? Maybe you already know, maybe you deployed some floats and you know exactly which floats you want to look at, but maybe you don't know. Maybe you just have an idea of a question and you want to see what's available. So the first thing we're going to talk about is sort of how do you find what floats you want? And then the next thing, once you do that, is to retrieve the data. And this is, there are several different ways to do this, and a little bit depends on kind of what format you want your files in and what other sort of questions and other particulars of your research topic. And I'll talk a bit about those and what, where to go for different types of files. And then last, you're going to open your files and start to analyze your data. And that's the part we'll cover kind of more specifically in the breakout rooms, because it kind of depends a little bit on your programming language. And then lastly, the fourth step is, of course, while we're all here, is to do science with the data. So we're not going to talk about that, but what we're going to do is just give you, talk about the first 3 steps to kind of get you started and get you set up and ready to do some science with this data. Okay, so there are multiple different access points, which is great because there's lots of options for discovering and retrieving float data. And it can be maybe, if you're just getting started and you don't know what any of these are, it could be a little bit confusing about what these different options are and why you would want to use some versus others. And so I'll just spend a few minutes talking about that. So these different panels all came from our GO-BGC website. And if you go there, go-bgc.org, and you go to data access and visualization, you'll see these different things, which all have links, and you can learn a lot more information. So the first thing I want to point out, though, is the first sort of one of these float data access points that we're going to spend more time delving into with the hands-on part of the tutorials. Is this the GDAC. Actually, let me switch. Before I get into the specifics, what I wanted to say was about sort of, I mentioned this before, what file format do you want? So there's several different types of file formats, and many of these access points let you access the multiple types of files, but some of them are specific to some types of files. So what do I mean by these types of files? Like the main two classes, and I totally stole this slide from Tanya's talk, and so thank you, Tanya. And but this is sort of my slightly adaptation of Tanya's much more thorough and much more informative description of these different types of files. But essentially, there are sort of two main types of files that you could get the data in. You could get the data from the GDACs, and that's the Argo Global Data Assembly Centers. And these are all in netcdf file format. And they use the Argo convention for the QC flags. And there's multiple types of files. So you can have a SPROF, which is our synthetic profile. This is particular to the BGC Argo files, but it's essentially the profiles that you want to use. There's also the trajectory information that's in a separate netcdf file called the trash files. There's a metadata file associated with each float, as well as some technical data. So there's a lot of information on the GDAC. There are no, however, derived variables. So this is sort of for the Go-BGC and BGC Argo community. This is one of the main sort of differences between these types of files, is that the Argo files have no derived parameters of any sort. And so if you want to use the derived carbon parameters that the Go-BGC and SOCOM program have computed, then you won't find those in these files. Otherwise, if you are familiar with netcdf, or you're learning netcdf, and this is really kind of for research purposes, I would say the netcdf files on the GDAC is the sort of go-to source, and in particular the SPROF. Want to make sure that those are the most easily usable profile files for the BGC Argo data. And then these are also archived monthly with a DOI, and the real-time data is available within 24 hours, and the DOI happens monthly, like I said. Okay, and then the other sort of type of file are the files that are produced by Embari and Scripps. And these kind of have two flavors, like the kind that you get from FloatViz, which Todd nicely showed. These are ASCII files, and they're compatible with ODV. So if you use ODV, then this is a great resource. They, as Todd showed, and I'm not going to really talk about ODV, I think, anymore, but this is also a really easy to use web interface, FloatViz, and it does contain the files that you can access here, which are text files. do contain the derived carbon parameters. So this would be DIC, PCO2, alkalinity. And so if you're interested in those, then this is kind of one of these, either FloatViz or the archived snapshots is the place to go. And there's both a high resolution and a low resolution format available. And that depends on the vertical sampling. And so many of the BGC variables are only sampled at a lower vertical resolution. And so that we have a file format where we take out the TNS data that aren't co-sampled with the BGC variables, so that you only have the places where you have BGC measurements, versus the high res has all the data. And these ASCII file form, the data that's in the ASCII files are also archived in these snapshots. These snapshots are nice because you have both an ASCII version, but you also have NetCDF. And so if you're interested in using the derived parameters, they're in these NetCDF, and you want to use NetCDF, then this would be the place to go. So this is currently done through sort of associated with SOCOM, but will be, all the MBARI float data are being archived through these snapshots. Okay, so once you know which kind of file you're really going for, then you can kind of start to decide how you want to access the data. And like I said, the GDAC is really the place to go for direct data access. And it includes all BGC Argo data, not just GO-BGC data. There's a lot of information that you can get by clicking on these links about how the data is formatted from the Argo data management team, as well as the BGC data management team. And this is what the index of the Coriolis GDAC looks like. So you have these profile index files that we'll talk about later in the hands-on tutorial. But so I think the hands-on tutorials in the different breakout rooms are going to be really focused on interfacing and accessing data through the GDAC via these profile index files. So I won't say anything more about that here. So I'll just say a little bit more about maybe some of these other ways to find and access data. So if you go to our website, so I think maybe I can hopefully switch sharing to our website. I'll try to do this. Okay, so now you guys see the GO-BGC website, hopefully, and the data access and visualization. If you go here to data access and visualization, you will find all of these links. So this is a really great starting point. As I mentioned, we're going to dive into the GDACs in just a moment, but there's also links here to an ERDAP server through the NOAA Polar Watch ERDAP server. So this is a really powerful way to access GO-BGC and SOCOM float data. It also has a lot of great visualization capability. So I'm not going to really say much about it here, but especially if you already use ERDAP servers, this would be a really handy resource. But if you want to find GO-BGC data specifically, another way, like I mentioned, was the FloatViz, which is linked here. And then we also supply our own map, our own interactive map, which you can find here if you go to array status, float locations, and data. And you can find this interactive float map, and you see our initial floats that have been deployed in the North Atlantic. So if I hopefully zoom in, you can hover over any one of these floats, and you'll find the WMO ID. So this is like the primary identification of the floats. You'll find also the last latitude, longitude, and date of the profile, the last profile, and then you'll find links, several links. You can go right here to the SPROF file at the GDAC. You can also click on this link. So float status from the Euro Argo. Maybe if I do that, there we go. Okay, so if I click on that float status from the Euro Argo, fleet monitoring, this is a really handy website, and it's one of several that kind of lets you easily view Argo data. This is not just for BGC Argo, but it's for any Argo files, but you can see here a lot of information about this float. You can see what kind of sensors were on the float. You can see what transmission system. You can see the information about when it was deployed 2 months ago, if it's active, how old it is, all sorts of different things. You can also look at the data plotted in a variety of different ways. So this is a really handy website to go to, and you can, it's also linked on that main data access and visualization page, but this is the main page for the fleet monitoring from Euro Argo, and you can, select data, select floats from all sorts of different parameters, and you can go down here to BGC, get only active BGC floats, and you click on any one of these. There you can see they're all listed by the WMO. One of these, for example. Okay. Another way to interact with the GO-BGC data is through this float table, and this is a really powerful resource too. If you know, for the GO-BGC floats themselves, you can click on this table and you can sort it by different ways, and all of these links give you access to files from the Argo GDAC, or again the Imbari ASCII ODV file. It's a text file. There's lots of information about each float. Okay, great. How am I doing on time? Let's see. Oh, let me see if I, okay, so that's kind of these main 4 float data access points. And then also wanted to point out these data visualization pages. This is the one that we were just looking at with the Euro Argo fleet monitoring, but we also have linked here to ArgoViz, which is a really great resource for looking at not just BGC Argo data, but also all Argo data, and encourage you to kind of play around with this website and see the different capabilities and functionalities. There's an API that you can use to interface with all the Argo data from the GDAC, and then here you see the BGC profiles are actually shown in green, and this is just a different way to visualize the data, and is a really nice resource. And there's also beginning to pull in various different gridded products and a lot of different cool applications are being integrated into the ArgoViz platform. And then OceanOps is another platform that lets you, or sort of website that lets you plot data from the whole Argo fleet, as well as other observational networks. Okay. So hopefully that gave you a good idea of how to get started with float data. And next we're going to break out into the different rooms for MATLAB, Python, and R. But if there are any questions before we do that, be happy to.
Quick comment, Alison. Ooh, I'm on twice. There's a chat that says NetCDF files only contain one profile. There are NetCDF files that only contain one profile, but the SPROF files have everything.
Yeah.
Just wanted to clarify.
Yeah, thanks, Ken. That's correct. As is the case for the TNS profiles, there are you can from in the GDAC there for each float has its own folder, and within that folder you can access individual profile NetCDF files, but then there is a file that contains all of the profiles, and that's usually, I would say, what researchers would interact with is either the SPROF or the there's like, it's just called prof.nc for the TNS files. Okay. Let's see. Any other comments or anything from the other organizers or the tutorial folks before we?
Well, Allison, I'm not sure if you saw some of the comments. Thanks, by the way, for the great intro. But it looks like we have having a bit of a technical issue with the breakout rooms. So George is, I believe, trying to assign people right now to 2 breakout rooms, but we just had, I think the issue is that he's not able to change the individual selection mode while the meeting is running. So, and I don't think the organizers are able to all simultaneously assign people. Yeah.
Can the co-hosts access the breakout rooms? I'm thinking it might just be easiest to make everyone in the meeting a co-host. So that they
I thought about that. That might be that or restarting the meeting, which seems undesirable.
Well,
is there an option to just assign everyone to one breakout and then everyone can switch to the one they want?
I don't know if it works that way, but can the co-hosts pick a breakout session to go into?
Yes, we can access to breakout session as a co-host.
Okay, I'm gonna go in and make everyone a co-host, and then everyone can pick what room they want.
Okay. But no one leave the meeting, or if you leave the meeting, make sure you just exit the meeting and not end the whole meeting for everyone.
Right. Yeah.
We're trusting everyone. And Mariah, could you make me co-host too? So I have 2 other instances, but since I'm going to be recording, just want to make sure I get in there.
All right, so sit tight while we all, and I think the co-hosts can also make other people co-hosts.
In the potential scenario that someone accidentally ends the whole meeting, is it the same WebEx link that people should click to rejoin?
Yeah.
Yes, absolutely.
Okay. Great. Please, no one end the meeting.
For some reason, I'm not seeing where you can join, like select a breakout session.
You're not listed as a co-host, Allison.
I know.
Yeah, I guess waiting.
Is it just taking a while to? Maybe that's it.
There, you are a co-host now. I swear I did that earlier. I'm sorry.
Okay. I see it now. How to join.
So I hope everybody can bear with us here. I'm not sure, George or Mariah, are you actively making people co-host right now? I'm trying to see if people are popping up as co-hosts, but I'm not seeing it.
Hi, this is Lynn.
Hey,
I'm
Lynn.
lost.
Yeah. We're having an issue assigning breakout sessions right now. We were not able to get people to choose their own breakout session. That's because I think that option wasn't selected when the meeting began. So we are trying to figure out how to either assign everybody co-host privileges so that they can choose breakout sessions or assign them individually. So I'm waiting to hear back. I don't know if George and Mariah are controlling it, but I'm not able to control the breakout sessions. If I click breakout sessions, it just says I can't edit it because someone else is editing it. So I'm not sure.
I'll just
George,
sit here.
yeah, George, I'm not sure if you're there or Mariah, but if you are talking, you're muted.
I also can't make, as a co-host, I can't make other people a co-host. That's blanked out. I guess it was the original people that started this meeting. I can do that.
I think because I'm a co-host, but I think it's George and maybe Mariah are the owners of the meeting. Maybe that.
So I do see people making it into breakout rooms. So I guess
all of the co-hosts should be able to assign co-host privileges.
no, it's well, I can't. It only says I can only make people presenter.
Neither can I.
Under the participant tab where it says change role.
Yeah, it's grayed out.
Oh, okay. All right. Well, I'm just going through them as fast as I can. People are making it into the breakout rooms, though.
Yeah, it looks like a very small number have made it into the breakout room so far.
There's some concern in the chat that there might be a maximum limit to
Yeah,
co-hosts.
that's a good question. I don't know the answer.
It might be a good idea to restart this meeting.
It's not. Yeah, I think that does sound like maybe that's a viable thing to do. I'm not sure how much longer to wait. If we're going to do that, I'd like to hear back from George or Mariah, whoever is controlling the meeting, before we pull the plug on it and try to rejoin.
Yeah, so George is occupied he's doing a different live stream thing right now. So, I mean, yeah, we can end it and come back in. I don't know that I'll be able to fix the breakout room problem because George set that up. So I don't know that we'd be able to do it without, you know, like undoing all the breakout rooms and setting them back up.
Mariah, are you in? Do you have can you get into the breakout menu?
Yeah.
I thought I saw a section there where you can assign everyone to one breakout. And then I think they can switch to another one from there once they're in one.
Well, now I can't. I'd probably have to end the breakout rooms, which is doable because the breakout session assignments is grayed out for me now.
Can we just use Zoom or Google Meet instead for the breakout rooms?
I don't think so.
Reset that up.
I'm gonna try. Is George presenting somewhere else?
He is on a BBC thing.
Yeah, he just walked away from his desk for this.
Okay. Well, let me warn the people in the other breakout room I'm in. Shall we try? It's a setting probably in WebEx, right?
Yeah, let's try ending the breakout sessions and then assigning everyone to one breakout session. So then people can hopefully change.
Yeah,
I don't. Yeah, I don't know if they're going to be able to change, but
perhaps just set up 3 new generic breakout sessions.
Just 3 sounds doable.
We'll be able to manage the help desk on the fly, connecting people who need help.
Okay.
For the help, we can use the Slack. We don't need channels for that here.
Yeah.
Yeah. Okay.
So I think the instructions is that we would be rejoining the same meeting link after it's disconnected. Is that correct?
I think, I'm not sure if Mariah is actually going to disconnect the meeting or just the breakout rooms. So I think she has full control at this point.
Okay, yeah, if Mariah's able to just reset the breakout rooms to 3, then we can go with that.
Yeah.
All right, so shall I end the breakout sessions now?
Yep. How you doing with it, Mariah? I'm still in the main room.
Yeah, I don't know that I can
Close
end
it.
the breakout rooms until everyone returns. So I keep messaging people return. It looks like everyone's back, but
Mariah, this is Heather Benway from the OCB office. Do you want May and I to just give our personal WebEx rooms the addresses out, and we can do 2 of them, and then you can just use this one for the third one?
Yeah,
sure. Yeah, that would be great.
idea.
Okay.
I also have a Zoom meeting that I just set up too for Python if we wanted to use that.
All right.
Yeah, it doesn't look like I can adjust these.
Okay.
Do you want
I
me
would
to make
stick
you-
with WebEx.
Okay. Yeah, well, so let's have the Python group stay here in this main meeting.
Okay. I'm just going to write these instructions out. May, can you put your WebEx room in the chat? MATLAB can come to me.
Yep, we'll do just a moment.
Thank you so much, Heather.
And R can go to May. She's going to put hers in there now.
I'll copy these onto Slack too.
And Heather, then when we join one of these, we shut down this WebEx?
Yeah, or you can just mute yourself so you can come back to it later.
Can I have two open at once? Oh.
Probably not, but it will be the same.
Okay.
If you want to rejoin.
And come back here at noon.
Heather and May, if you could also record in yours, that would be helpful.
Will do.
Thank you.
Yep, no problem. Everyone, you can find my link for the R room in the chat. I'm going to leave it for just a moment, and then I will be opening that meeting when I close out of this one.
Okay, so Python tutorial folks, can you all share?
So I
think we're all good.
Yeah.
Okay.
So there are 88 folks here, which is
Hi.
hello, a little bit higher number than I think I expected, given the proportion of
I think it's dropping quickly.
Python users.
Yeah, let's just give it a little bit of time. I think some people might have also joined the other meeting with this one just like minimized.
Mm-hmm. Just to make sure.
Yeah.
I think it's okay if we get started.
Yeah.
So I think first we can introduce ourselves. I'm Ethan Campbell. I'm a PhD student at University of Washington, as is Katie Christensen here, and Katie and I will be running the Python tutorial. Ryan Anderson and Rue Nicholson are here, and they will be monitoring Slack, both at UI, and hopefully monitoring the WebEx chat too. And if you have questions, feel free to put those in the WebEx chat or Slack. There's more of a complicated technical question that's a bit longer, than maybe Slack is easier, but we'll be watching both of those. And before we start, just want to make super clear, so there's a little time in case you haven't done this already. If anyone does not have a personal Google account, so not an institutional one, like if you have one through your university, if you don't have a personal Google account, we are recommending that you use one of those for this tutorial. If you have an institutional Google account and you know it works with Colab and you've used it with the Google Drive integration with Colab, then great, awesome. If you're UW, you're fine. But we do recommend you have that. So it's quick to set up. Just go to google.com. That will get us situated. So it looks like we have 56 people here, and it's pretty stable. So I'm going to share my screen. And did test this, so hopefully it works. I think we'll have to keep this way. How's this looking for everyone? Katie, is it okay?
Yeah, I think it shows up just fine.
Good, good. Cool. So it's 11:06, and yeah, let's do this. So I think the place that we're going to start from is this GitHub link, and I'll put that in the chat just so you'll have it. Let's see if I can move the chat over here. Okay. So this is the workshop Python repository on GitHub. Robert's asking how to get back to the MATLAB session. So MATLAB has gone over to a different WebEx link, and that is, let's see, just put that in the chat again. Yeah, hopefully that works, Robert. So we're going to start at the Python repository, and this will be here after the tutorial is over, so you'll be able to access these resources later. And there are a few steps to get started. Pretty simple. We're going to just follow these one by one. I should mention, though, if you want to just follow along without actually coding, you can do that by clicking on this link and viewing a non-fully interactive view of the notebook that we'll be going through. So here's that link. You can just follow along, and you won't be able to play with the code, but that's a quick way if Colab is not working out for you. And for anyone who can't access Google, and I'm thinking here perhaps people in different countries outside of the US, if that's an issue, then you can always download this, the Python notebook, and run that locally. And if you need help with that, I'm sure there are folks who can assist here. So the very first step we're going to do is go to this first file, or you can click on the link here. GO-BGC workshop Python tutorial.ipynb. This is a Python notebook, so it's a bit different than a script. And the next thing to do here is to click this Open in Colab button. And it's over here, so I have the instructions. And this is really nice in that GitHub integrates with Colab directly. So once you do that, you're going to access this view of the Python notebook. It should look familiar for anyone who's used them. But you'll notice that if you start trying to edit it, you can't save these changes. This is sort of just a read-only view. So the next step is going to be to click this copy to drive link. And what this is going to do is create a editable version saved in your Google Drive. And also, I should say, if you haven't logged into Google yet, you should probably do that. Choose that personal account. When you click this link, it may open it in a new tab automatically, or you might have to click. But either way, you should get this new editable view, and I'll post in the Slack for Drew, who was just asking for the GitHub repo link. There we go. Okay, so now you should have this view. It should say copy of GO-BGC workshop Python tutorial. And this is the version that you're going to be working with that you can change. It won't modify the GitHub version, so this is all, you're free to do whatever you want in this notebook here. I should mention that this tutorial is geared towards newer users. So those of you who are more experienced with float data, some of this is going to be review. But our hope is that everyone will come away from today with something new. I think it should be a fun time here. So we've reached this point. Want to know if anyone is having trouble getting to this point. And if you are, you can use the chat in WebEx, or sort of these emoticon. There's some reactions somewhere in WebEx. Like a thumbs down.
The request to increase the font size to zoom in a little bit.
Yeah, definitely. Thanks, Nancy. Hopefully this is easier to read.
That's great.
Cool. Okay, so I'm seeing no issues with Colab. You're all at this point. That's good news. And what this has done is it's saved in your Google Drive a copy of the notebook in what should be the folder Google Colab, or Colab notebooks. Okay. And it should be there. You can move it in or out of that folder into a different place if you'd like. How do you get to the notebook in Colab? So that's starting from the GitHub link, following those instructions in the repository that was linked over here. I'll put that link again. Clicking on the notebook file, clicking open in Colab, and then clicking copy to Google Drive. Eric, let us know if you have any issues with that. Okay. So I think hearing no other other issues, I think we're good to move on, and I'll hand it over to Katie for this next section.
Great. So now that everyone hopefully has a copy of this notebook primed and ready to go, we're going to talk about getting it primed in our Google Drive and setting up everything to actually run through our code. So this is going to be entering into the Python programming world, and we're going to open up that first setup bit, drop-down menu there, and you can hit the little caret next to it there, and that'll help us move along. All the sections are then numbered in that way, and we're just going to move through the different sections. So at the very top, we have some information about this general workshop, just underneath the GO-BGC workshop title there. If you have any questions, like we said, put them in the chat. That's happened quite a bit, so thank you guys. People who created this, we did all the introductions, and then attribution. So we're using GO-BGC data for this, and SOCOM data for this tutorial. We ask that if you use these things in your research, please acknowledge them and do all of the proper acknowledgements. You don't have to acknowledge this code with formal attribution, but we want you to link to our GitHub so that other people can find what you're doing and get cool research out of it. So now getting set up for our Google Colab. The reason we're using this is because it's free, cloud-based, so we're not running anything on people's computers. It makes it easier to translate between machines, and it's a Jupyter Notebook platform, which is pretty easily human readable. Couple of how-tos on this. These cells are either text or code. The code, you can see it's kind of in the little gray boxes, and then the text, you can see Ethan is clicking through that. And you just can run these by hitting Shift-Enter or Shift-Return, or there's usually a little play icon on the left top corner of the cell, and you can run your code in that way. If something isn't working, if it's for some reason breaking down, you can restart your runtime in the runtime drop-down menu on the top there. And you can see there's a restart runtime, which since we haven't run anything yet, you can't restart it, but as soon as you do, you can restart it in order to make things work better for you. Hopefully that's clear for everyone. You can play around with it a little bit. It's very similar to Jupyter Notebooks if you've worked with that format at all. So let's go ahead and actually run our first cell here. The first time we run this cell, we're going to be asked to navigate to a link. You're going to click on the link, and what this is doing is giving it access to your Google Drive. So that means you can put data files, open up new folders, and that kind of thing in your Google Colab notebook. So you can go ahead and step through clicking on our link, and you're going to have to select your account. This is why we suggest you have a personal account. It just allows that access. So signing in, and you're going to copy this link in order to put it in as an authorization code. We're going to take a minute here. I want everyone to give me a thumbs up reaction or put in the chat if you're having issues, and hopefully this is going to be working out for everybody here. Great, seeing lots of thumbs up, that's good. Yeah, so at the very end here, you should see mounted at /content/drive, and that should be now primed into your Google folder, Google Drive, and able to access those things. Yes, you can see all of Ethan's lovely folders. All right, so now that we've accessed our Google Drive, we're going to actually start loading things into Python and sort of opening up our important packages and getting some of the coding stuff ready to actually read our data. So we're going to run this cell. It's got all of our import statements, and there are a couple packages that aren't in the default packaging of Colab. So we have to do a pip install with the exclamation point on that top there. And that just gets us those packages into Colab so that we can use them. And then we have all of our import statements. And then finally, we have a bit of code that will now open up and create new files on your Google Drive. So this file will be called GO-BGC Workshop. And inside of that, there will be two other directories called Profiles and North Atlantic. And that's where we're going to be putting the data that we're using in our workshop today. So hopefully everyone can run through this and there are no issues with the import statements. In Python, we need these packages in order to use the tools that they have in them. So great. If anyone is having issues, speak out now in the chat or with a thumbs down reaction. Otherwise, I think we are going to move along to the actual functions to download our float data.
Super. Okay, so we are on part 2 here, and I'm going to unhide the cells. Thanks, Katie, for stepping through that. So we are all set to start coding, and what we've done here are write 2 functions that we think are broadly useful. We won't go through all the code in this. You're free to borrow these for your own research. The first is called download file, and it basically just downloads and saves a file from any given URL. It has some options you can select where it's going to download to, that's save to, whether it's going to overwrite existing files, and whether it's going to tell you what it's doing. And this uses the requests library in Python to download files. And it's not the most resilient code, but it does have a bit of error handling in case the download doesn't work well. Now, the second function here is called Argo GDAC. And this uses the GDAC index file that you heard about from Alison and earlier on Monday from Tanya. And the GDAC index file, again, is this in either the US GODE or the Coriolis GDAC, it's this synthetic profile index.txt file. And it has an index of every single float profile that you could possibly download, as well as some metadata. So what the function does is it downloads that index file, which is about 30 megabytes, and then it uses some criteria that you specify to choose certain float profiles. They can be geographic criteria, Latin long, start date, end date, particular sensors that you want to make sure the float has, or specific floats if you already know the WMO IDs of those floats. Again, you can step through this on your own time if you're curious. There's a bit of documentation about how to specify these arguments. So this is some versatile code that we hope will be useful for everyone. And then at the very end of this, if it does download files, it returns a few variables. It returns the WMO IDs that were downloaded. It returns a view of that index file that has been subsetted. And then it returns a list of the file names that were just downloaded. So what we're going to do is go back up to this first cell, the download file cell. You can run it again by clicking the play button or by going Shift-Enter on your keyboard, or Shift-Return. And all that does is it's loading this function into the namespace of Python so you can access it later. So nothing really seems like it's happening, but you're just running that code to load the function. And let's see. I think would the function work with core Argo stuff? We have a question in the chat. It would with a very small number of modifications. You'd have to change the file name and just make sure that the columns all match up. But yeah, it should be helpful there. I think that's it for the section. So we're gonna hide this and move on to 3.
Yeah, so great. Now that we have those functions, let's go ahead and actually do an example case of using the functions. And we're going to give the example where we know the single float that we want to load. So we're going to say we know the float's WMOID, which we're going to be using float number 5904183. And we're going to plug that into our Argo GDAC function. So we're not going to bother with the latitude, longitude, start and end date. We know the float number, so we can just put that as our argument. Everything else can be none for the narrowing it down. So if you go ahead and run this, like Ethan said, it will give you 3 outputs. It will give you the WMOID, which in this case is exactly the number I read off. It will give you the GDAC index, or no, sorry, it will give you the downloaded file name, which is, of course, the float number and the sprof.nc, and that's the format that it's in the GDAC on. And then it does give you the GDAC index heading, which here we can see the first 3 lines we printed out at the very end here. You can see that it's got the file, the date, the latitude, the longitude, that these profiles, which these are the individual profiles, you can see that it's the 001.nc, 002, 003, and those are the individual profiles in the GDAC index file. So we've actually loaded the data from this float, and it should be saved into your Google Drive.
And it should. And we have a question in the chat from Joan. I got name error. Name Argo GDAC is not defined, and that means you probably haven't run that cell of code up here in section 2 to actually load that function into your namespace. So just run these 2 cells here.
You have to run both the cells. You can't just run,
Yes.
run the first one.
Yeah, there are 2 cells. These 2.
Is anyone else facing an issue with loading this, or has everyone managed to get their WMOID, download file names, and GDAC index things to work nicely? Lots of thumbs up. That's great.
Good, good. Why are there 3 NC files?
Yeah, so those 3 NC files are for the individual profiles, whereas the full sprof file is all of those compiled together. So you can see here that it says AOML 5904183/profiles/SD, the same number, 001, and then 002, 003. And that's just the first profile, the second profile, the third profile. The actual S profile is going to be in AOML 5904183/ the file name, which is the downloaded file names output that we got from our function.
Yeah, so you'll see it in Google Drive in that GO-BGC workshop directory that was created. You should have now the single sprof file. And yeah, we do find that easier to work with than the individual profiles. Okay.
Yeah, the individual profiles are nice if you are looking in just a specific geographic area and you don't care about what float number it is, but you want everything just from that little area. So you can select out the individual profiles and maybe not worry about the float number, but in general, it's best to keep them together and whole.
Mm-hmm.
All right, I think we're gonna move
Super,
on
okay.
to our
Part 4, yeah. So part 4 is loading this netcdf file that you downloaded. And let's unhide those cells now. And the package we're going to use, as I think we hinted in some of the email communications ahead of this, is the Xarray package. And Xarray is really the gold standard today for loading netcdf files into Python. There have been other ways to do it, but most people use Xarray now, and it's so easy. The function that Xarray has to do that is called open dataset. And we're going to do that in a single line by saying XR, which is the shortcut for Xarray, sort of like NP is the shortcut for NumPy. Open dataset, and here's your directory path that was set in the very, I think, second cell. And downloaded file names, ~0 is just using the first item in that list of the downloaded file names. And we're saving that Xarray object into the variable called data. Okay, so the second line, don't have to worry about this too much, but we're just swapping some dimensions, setting the cycle numbers as a coordinate to make that easy to use. And then the way that you view an Xarray data set is just by using this display function. You can also just type data if it's at the end of the cell, but display data is most clear. So let's run this code. And what we get is this really nice interactive view here. And Ru just put in a nice little comment in the chat there about the file structure. So let's see, what what we can learn from this is that to start on this very first line, X-ray tells us the dimensions. We know that there are 7 parameters, that's n param here. There are 233 profiles in terms of profile numbers. And then the maximum number of levels in this data are 557. Okay. And for each of these variables, if you click on this data variables pane, this opens up here. And I'm going to zoom out a little just so we can see more. There are 78, so there's a lot of data in here. And you can view the metadata for each of these variables by clicking on the little page icon on the right that pops open the, say, the long name, dimensions, and you can actually view the data in some cases by clicking on this cylinder icon on the right. So it gives you a window into what the data look like. So I think we have a few sort of interactive questions just to get people's brains working and fingers typing. And the first one is, if you were to look at the profile number dimension and the profile number coordinate, and these are different things here, how many profiles are included in the data file? We put this in the WebEx chat. And then how many profiles have actually been collected by the float? And these are 2 different numbers, and this is sort of an exercise to explore the pane here. So anyone can feel free to answer those 2. Number of profiles versus the number of profiles in the data set versus the total that have been collected by the float. Yeah, Nancy, 233 profiles, 244 in the data set. And how do we know that? It's because profile num is 233. And if you look over here at the coordinate array, you can see it starts at 1, it goes up to 244. So while there are only 233 provided, the float has actually taken 244 profiles in total. We just don't have all of them in this data. For various reasons, it could be, I think in this case, the float is at the end of its life and it didn't manage to transmit all of its data. Okay, next question. Exploring some of these variables, what are the units and long name of the variable BBP 700? Anyone but Nancy can answer this one. Eric asks, has the SPROF merged the BD and the SD data from all the individual profiles? Not familiar with BD. Maybe someone else can answer. Yeah, wow, we have great answers from Pirseb, from Drew, and from Joel. It is indeed backscattering coefficient at 700 nanometers, and we know that because if we scroll down to BBP 700 and we look at the long name in this little attributes pane here, we can find that. It also gives you the units and some other metadata, including the resolution. And you can see how many values there are, 100,000 values there. That's great. Okay. And since I think we took a little time, I'm just going to answer this next one. On what date was this data file created? If you scroll down to the very bottom, you can see metadata that apply for the entire file, right? And that's in the history. You can see the creation date. It was created on May 14th, and you can see the version of the Argo data that this is. Just a little comment about the structure. You'll see at the top there are a lot of sort of forms of metadata and the dates, latitude, longitudes that have dimensions of time, profile numbers here. And then at the bottom, you'll see that there are grouped in sets of 5 or 6. These are the actual variables. So pressure, temperature, salinity, oxygen, et cetera, that are measured. And you'll see that, for instance, there's temperature QC, temperature depress, which is the displacement from the actual sample value, is usually a small value because this is the merged profile. Temp adjusted QC, or a temp adjusted, and then temp adjusted QC here, and then temp adjusted error. So for each of these, there are different variables that we'll find useful. Okay. So I think this is the last part of section 4 here. We're just going to use this data and very quickly using X-Array's magic plotting library to create a quick scatter plot of longitude versus latitude. So this is where the float has profiled So we're doing dot scatter, longitude, latitude. You don't need to know the syntax. It's just a shortcut. And we're coloring it by position QC. So if you run the cell, you'll see that we get two different colors where position QC, meaning good positions, are blue, they're 1. And then QC flags of 8 for position, which indicates positions have been estimated by interpolation. Those are orange. And you can see very clearly this float was from the Southern Ocean. It lasted 6 or 7 winters, and each time it went under sea ice in the winter, those profiles positions have been estimated by interpolation because we don't have real fixes for them. So that's what's shown here, and we're going to move on to section 5 now.
Okay, so let's go ahead and talk about the date-time integration, which is actually this is a nice section because X-ray does a lot of it for us. So let's take a look at the timestamps of our float here. And we can do that by accessing the file that we've loaded in by saying data, square brackets, and then Julian days, JULD. And you can see it prints out this X-ray data array with quite a bit of metadata. And you can see in the numbers, the data type is this date time 64. Sometimes we don't want all of that metadata and that extra stuff, we just want the numbers. So we can access that using the dot values function on our data accessing Julian days. So in the quotes, JULD dot values. And if we print out the first 10 of those, you can see it gives us just the numbers, none of the extra metadata. But if we check the type, it is still a NumPy date time 64. So it still plays nicely in the dates that Python has set up. So you don't have to do a lot of formatting in order to make that nice. We can access any other data variable, or in this case, we can access the profile numbers using the same formatting, the square brackets and the quotes, and then you can say dot values to just get the numbers. And we can do the exact same test that Nancy gave us the answer to before, checking the number of profiles that have been sent to us versus the number of profiles that have been taken. So you can do that using the length function, len, of the profile numbers, which is what we just read in. You can see there are 233 of them. And then you can check the actual numbers by using indexing. In this case, we've indexed -1, which is just the very last item in the list, which is 244. So you can see there are 11 profiles missing somewhere. And if we plot that with our time, so in the next cell, we have our scatter plot with our profile numbers on the x-axis, our timestamps on the y-axis, and a couple of other formattings with the color and the size of the dots. And we have our X and Y labels, and you can see at the very end is where we start missing those last 11 profiles. And as Ethan said, it might be because it's the end of the float life, it might be because it hasn't gotten transmitted past being in ice, for any number of reasons. So that's how you can access into the data that we read in and sort of start to play around with those numbers without having to carry all of the extra metadata using that dot values. So now that we've gotten that, we can move on to other variables, like in number 6.
Super, okay. So we're going to look at pressure because it's you have to use it to interpret really any of the other variables. And I just want to make the point that as you've heard from others, I think it's particularly Tanya on Monday, we should always be using the adjusted versions of data. I don't think pressure gets adjusted often, but in general, it's best practice to use the underscore adjusted versions. So we're going to view that in its X-ray format, so we're not doing dot values here. And it tells you that there are 557 depth levels. Now, since this is a synthetic profile, that means that not every vertical profile in time necessarily has 557 depth levels. That's really just the most possible in this file. And if we look at the attributes, you can find that pressure is in decibars. I think that's what this is showing. So if you wanted to, for instance, extract the units for, to use in a plot label or something, you can use that this .attrs syntax. It gives you back a Python dictionary, and you can access that pretty easily. So going back to that important point about the 557 depth levels. So if you look at dot values here, you can see the structure of pressure is a 2D array. And going vertically here, this is going in time. So this very first line is the first profile. If you look at the end of these profiles, you can see that they end in nan values. Nan is not a number. And this is essentially padding to make these all a uniform length, even though they all have different numbers of actual values listed. So for instance, this profile here has 3 nan values at the end. And this gets to the challenge of working with SPROF files that we have to deal with, and that each of the profiles are sampled at different points and that they're different lengths. So we're going to use indexing to index into that this 2D array structure and get out that first profile. And there are 2 ways to do this. In X-ray, if you watched that sort of tutorial video before this, you'll know about the .icel notation, or if you're familiar with X-ray, you can do .icel profnum equals 0. You can also just use standard Python brackets indexing, which is a bit less clear what's happening, but that gives you the same thing. So we're saving that into this variable called first profile pressure. And these do the same exact thing, these 2 lines. We're going to examine the first 10 and the last 10 pressure levels. Again, we can do that using the display function for X-array. And you can see that the pressure for this profile starts at around 5 decibars. It ends around 1599 decibars, so about 1600 meters. And again, you can see the padding at the end. One thing to notice is that the sampling is a lot more frequent at the surface, the sampling interval, and then at depth, it's about every 100 meters. So that's something to keep in mind, that the sampling pattern changes at around 1,000 meters for floats. Okay, I think we're gonna move on to 7 now. And if there are any questions in the chat, feel free to just put those in and can try to answer those.
Yeah, so just like every profile doesn't have all of the pressures, every sensor doesn't measure at every single pressure either. So we're going to sort of dig into that. We're going to look at the salinity, which accessing again in the same way that Ethan said above, with the dot values bracket 0. So accessing it using the sort of NumPy array instead of the X-array icel type format. So if we display that, you can see that it is very full, right? Every, for at least the first 50, every single pressure measurement has a salinity measurement to go with it. If we look at the exact same access of the nitrate, and remember, we're using the adjusted data for both of these, you can see there are lots of nans filling in all of this. And that's just because the nitrate isn't measured at every pressure level. It's measured, it looks like every third at the beginning roughly, and then sort of moves on to a few different levels. So keep that in mind. It's not always going to be completely filled in with all of the different sensors, and you might have to deal with some sparseness, which we will talk about in the next section if Ethan is still there. I think your video disappeared.
Uh-oh. Maybe start that. Is the screen still showing though?
Your screen is still good, yeah.
Good. Okay, just restart a video, hopefully that's working. But it's okay if it isn't. Well, let's move on to section 8, plotting a vertical profile. And thanks for sticking with us for all that, all the stuff above that wasn't the most exciting, but I think this is where it gets more interesting. So what we're going to do is use the Matplotlib library to create a simple line plot of your nitrate values versus your pressure values. And we quickly see that there's a problem here, and that the deep values are showing up, but the near surface values are not. And Annie has a really important point in the chat there. R means the file only contains the raw data. D means that it contains both raw and adjusted data. Yes, and B is BGC, S is synthetic. Yeah, the nomenclature is so important there. And I'm guessing you all can figure out what's going on here, but just to make this more clear, if we use scatter instead of plot, so we're plotting just the individual points that aren't connected, we get the profile, the full one, like we're supposed to. So what's happening here? it's that sparseness, the fact that there's a lot of NaN padding, and the NaN values are not being connected by Matplotlib. So what we have to do now is mask out to extract out the good values and leave behind the NaN values. And we do that using NumPy's isNaN function. So that creates an array of Booleans, so true or false, where true represents NaN values, false is actual data. And we're going to save that as this variable called mask invalid levels, some descriptive variable names here. And we're going to then invert that using the tilde symbol, so true is now going to be the data we want. And what you can do with a Boolean mask is use Python brackets indexing to extract out certain index values. And we're going to index into first profile nitrate using the mask we created. And what we find is that the NaN values are ignored, which is what we hoped. And now we have all the valid nitrate values from the surface to the deep. And there are a lot fewer of them because nitrate is not sampled as frequently as salinity. And there are no NaN values. So that's great. We can now plot the entire profile as we were hoping. And we're going to do what we just showed here in these 3 steps, all in a single line of code. So we're going to do first profile nitrate, brackets, tilde to invert that Boolean array, np.isNaN, and then the original nitrate values. So hopefully it's clear what's happening here, and what we get after extracting out only the good data is the line plot that we would like. So this is kind of cumbersome, but it is something you have to do when you work with sprof data, and when you're working with BGC data that's sampled sparsely. Okay, and I think we're moving on to section 9 now.
Yeah, so another thing you have to do when working with any kind of Argo data is checking the QC flags and making sure that you're using the adjusted fields. In this section here, there should be a table, but if it's not showing up, as you can see, Ethan's isn't, you can follow it at the link that is right there. And that just
happens
outlines,
if you're in Safari. If you're in Chrome, it should be fine.
And that just outlines the different quality control flags and what they mean, especially between the real time and the delayed mode versions. And remember, delayed mode is, it's been gone through all of the system and been corrected, hopefully, if it needed it. And then the real time is it's just gone through the base automated level of quality control, but it hasn't gone through the whole process yet. So in general, it's best to use 1s or 2s. 0s is no QC has been performed. You can use it, but use it at your own peril. 3s, 4s. The further down you get, the less likely you should be using it. That's an oversimplification, but for our purposes, we're going to be going with that. So let's just take a look and sort of visualize why we should be using these adjusted values and looking at the quality control in order to check these things. So we're going to access the nitrate quality control and the adjusted as well as the values of these things. And we're also going to access the times and the levels that these were taken so that we can get a nice picture over the life of the flow. So we're going to create these subplots we're going to create these subplots of the pressure and the time for each of the parameters. So the nitrate adjusted, the nitrate quality control flags, and then the nitrate adjusted quality control flags. So those are all of the different variable names that we're going to be digging into. And just like always, we are going to be doing that with the square brackets and then the quotes around the variable names. And we're going to be plotting them as lines. And if you scroll down a bit, you can see sort of these 4 panels that we've created with all of the different values here. So you can see in the very top left, this is the nitrate parameter. So these are the numbers that were given back, and they're not the adjusted values. And you can see that there are a number of values that are probably not so good. A bunch of it looks like pretty close to 0, or maybe even negative, right? In the middle there. And you can see if you look at the QC flags, those are flagged as 4s. That's the purple color in there. And the other ones are flagged sort of green, which in this case is 3s, right? So 4s and 3s, and those are just for the non-adjusted values. If you then go and look at the adjusted values, it's dropped out all of those, bad ones. They are marked with 4s, which if you go to your table, a 4 is data that have failed one or more quality control tests, or bad data that is not adjustable. So if it's not adjustable and you can't fix it, we're not going to be using it. And you can see here that now the QC flags have changed to be 1s, where the data is now marked, now being plotted in the nitrate adjusted. So going through my list of things, and yeah, so it's a double lesson here. Use the adjusted values. Make sure that you aren't trying to plot data that can't be adjusted and it's just residual. In order for if you want to look at the residual stuff and try and fix it, great. But it's a hard process. And then the other lesson is to always check your QC flags. Make sure that you're trying to use flags that are appropriate for your work. And for most scientific work, that's going to be a 1 or a 2.
Mm-hmm.
So.
Thanks. And there's a great discussion in the chat there. Definitely, the comment from Annie is good. We aren't going to be showing the adjusted error variable, but that's a good one to reference. And I think what Nancy was showing here or mentioning is that even in the adjusted QC flags, you can see a mix of flags. You can see that the more recent data has probably only gone through the automated QC check, and therefore, instead of this was probably good data here being flagged as a 1, it's still flagged as a 3, which is bad data but potentially correctable. And why is it bad data? Well, if you look at the difference between the nitrate and the nitrate adjusted fields, you can see that there actually is a difference in the values themselves. These are on the same color bar. So there has been some offset or gain correction applied, and the values themselves are different after this correction. So you do want to be using the
It's
the
also
adjusted.
possible that is hasn't gone through the full process yet, right? It's only been a few months since that time period, so it may not have gone through the full process and gone through all of the quality control corrections. I believe it's supposed to be about 6 months, right? For the real time to delayed mode. I think it's getting faster all the time, and people are always working on it. But yeah, the later you get in a float's lifetime to our current time, the more likely you're going to be running into the real-time data as well.
Mm-hmm. Yeah, a really good question from Pierce Sub in the chat. Do we ignore those 3s? It all depends on what your purpose is. If you're assimilating this into an operational model where you really need good nitrate data, maybe you don't want to use data that hasn't been checked, but you need to because it's you need the most current data. Maybe for research purposes, you might not use that, but it is totally up to you. And I should say Andy here is our QC expert with the GTAC. So all of our answers here are really good ones. Can the QC flag be empty after the adjustment? I don't think I've seen an empty QC flag. Purple, yeah, there's in the chart here that QC flag 9 is missing values, but yeah.
The values may be missing, but the flag should never be.
Yeah, this is I think the big thing that a lot of people miss when they're starting to use Argo or BGC Argo data, and they you're really excited about your research and you don't look at the flags, and then you end up using data that potentially has a drift or a bias, and or it's potentially just really bad. So always look at the QC flags. So we're going to move on to section 10 here. Is all real-time data marked at 3 or worse? Yes, for BGC data. Okay, interpolating. So again, there's some code here that we're not going to totally dive into, but you're free to look at what's happening after the fact, and to use this code in your own research. This is not research quality code. It's not perfect. It will not handle every edge case, but it does get the job done for what we're trying to do here. So As you saw that when we used Matplotlib's pcolor, it was just plotting the depth levels that were sampled. So if we want to interpolate that to create a more smooth, usable, nicer looking time depth section, we have to interpolate to a regular coordinate in pressure. And we're going to do that using SciPy's interpolate .grid data function. And we've created a simple function to do that, or actually a few functions. The first two just, it converts between, these convert between date time format to float, which is necessary for interpolation because SciPy can't handle date times. And then this next function is a bit longer, and it uses that grid data function to interpolate. And basically what's happening here is you're creating a new grid using the existing times and then a regular pressure axis, and meshing that to 2D grid. And then there's a little code to specify only certain QC flags. So if you want to exclude, for instance, QC flag 3, you can do that by using this, the arguments in this function. And then it outputs the gridded parameters as well as the coordinates. Okay, so this is a really quick overview. Since we're short on time, we're just going to go down to what that looks like. So if we run this code, we're interpolating dissolved oxygen. And this is not the adjusted. We're doing, oops. So you have to run this code to actually save the functions. Okay. If you run this, we're doing exactly what we said not to do, which is to use the non-adjusted data. But you can see here, it's great, it's pretty, but there is very clearly a bad dissolved oxygen profile. Okay, so this is interpolated. These are just the upper ocean depths from 250 above. Here we're doing the same thing. That function can also take in the QC flags and interpolate those. So this is doxy QC, and we see that indeed there's that bad profile. It's flagged as 4, but there's also one that we wouldn't have really noticed looking at this. It's really not obvious that that's bad data, but it's flagged here using that QC flag. So it's really, really important to use this. Here is doing what we were supposed to do, which is using the adjusted version. Same code, going to run that, and you can see in the adjusted parameters that bad data is masked out, or it's gone. We've also specified using that argument and function we created, specify QC flags to only use one QC flag 1. But if we didn't do that, it would have looked the same. So here's sort of what we're expecting, all good data. And just to show that you can do that with any other parameter, we're doing that with temperature here. You get a nice plot of temperature, the adjusted version. You can tinker with this and change this param name variable here into, for instance, psal for salinity or nitrate for nitrate, and rerun this code and have some fun with that just to see what those look like. But I think at this point we're going to move on to section 11.
Yeah, so this is our last section here. And now we're going to be looking at more GO-BGC data. This past float we've been using as an example is actually from SOCOM, which is great. But let's look at GO-BGC because this is what the workshop is for. So what we're going to do is we're going to download the data from multiple floats using our same function as before, our argo GDAC function. And instead of giving it just the float numbers, we're going to give it our latitude range, longitude range, our start date, our end date, and then the pH sensor, which is a very telling picture of that it's a GO-BGC float. And what this should do is select all of the GO-BGC floats in the North Atlantic. Yep, Ethan's got a lovely map there. So if you go ahead and run this, it should then put all of these files into the folder that we created on your Google Drives. And they should be named with the float number and sprof.nc. You can see that it's now loading multiple files, whereas before it was just loading the single file, and that's just because of the different arguments we put into this function here. So hopefully that runs for everyone. If there are issues, go ahead and toss that in the chat and we can try and diagnose it. But from those files that we've just loaded, we're going to actually put them into an interactive map using Plotly. It has been created by Ryan, And Ryan, if you have things that you want to say about how this was created / what to look at, go for it.
This is actually really straightforward. So we're looking at, we're using Plotly here, which is a nice interactive plotting tool. So you can actually click around and scroll all over the map. It is just pulling out the data from all those profiles that we're looking at. So we're not looking at the directory data here. It's just all pulled from metadata. So Ethan here can kind of show that you can click on things and zoom on things. It also has some hover attributes, so you can scroll over data points and see some of the attributes of those things. And that's all fully customizable. So if you wanted to create a plot with your own information or different data, you can do that. And one other note, since we're really low on time here, is that the base map you can also customize. So this is pulling from Mapbox, but if you want, you can go into Mapbox Studio, create your own account, and really customize your base map if you're looking for something fancy. So there you go. Broad overview on that.
So our hope is that you can use this code in your own work and adapt it as you will. We've hopefully given you a handful of tools that you can use, Plotly, Xarray, all those things. Hopefully helpful for you. And I guess it's a couple minutes until everyone, so I can take questions, comment on ArgoPi. It'd be in the works, and functionality will sort of overwrite a lot of things we've done here. Until that time, I think this will hopefully get us by. This is, as Ethan said, not like research code. It's code that you can use and adapt for your research. So
yeah, ArgoPi is great. They're doing fantastic work, and they're in the process of making it compatible with BGC data. So hopefully that will be a unique, a useful tool at some point. Yep. And for this function, you can play around and you can change the parameters just to check out the different data that our really brand new GO-BGC array has been sending back over the past year. So thank you all. We'll be around and able to answer questions on Slack if you have any, as well as in the coming weeks if you start using this data. Happy to answer questions too and help out. And I think I'm going to answer any questions in the chat rather than out loud here and in the screen share. But thank you all for participating in this.
And just a reminder, if you leave the meeting, make sure that you don't end it for everyone.
Jesus, it looks like you have a good question about missing profiles being related to problems with data transmission when the buoy rises to surface, or some quality flag was not reached for different variables. I know when the Argo float is under ice, it has to store all of those profiles and then finally transmit it. So it is possible that it does send the information more than one dive if it had a previous issue sending it. Does that answer your question, sort of? Yeah, great. Annie, I'm sure your answer is better than mine, so go for it.
Hey guys, sorry I didn't mean to crash the party. There's a difference between the number of cycles that a float has done and the number of profiles that a float has collected. Sometimes, when the float has done about 100 cycles, it doesn't mean that every cycle the float is working properly. So sometimes when there's instrument malfunction and the float somehow is unable to collect a profile, then there will be a missing profile. And when there's a missing profile, we do not put a profile file out there. So when the GDEX concatenate all the profiles into the asprof file, you'll find missing profiles. So it means that for some reason, the float was not able to collect a profile. Now, under ice profiles are different. They are collected. they're just transmitted a few months later. But when they're transmitted all in a bundle, so they will all appear on the GDAC all at the same time. The GDAC doesn't, there will be no missing profiles because of under ice.
Great. Thank you for that answer. So the Python tutorial has wrapped up for everyone who's logging back on from the other tutorials. I don't know who is taking over next, but I think we are ceding control.
Yeah, thank you all. So I guess we're reconvening in plenary now at 3 o'clock, at 12 o'clock.
Right now, right?
Yep.
Okay.
Yeah.
So I've lost co-host control, but I guess I can just pop in and oh, can you hear me now?
Yep, I can hear you.
Okay. Yeah, sorry. I lost my co-host privileges, but I think we have 30 minutes right now to go through a few speakers, I think beginning with Pete, and we're going to hear from a couple of our international collaborators, followed by program managers. And I will just let them pass it off to each other, trying to keep it to 7 or 8 minutes or so. Each talk should give us about 30 minutes. So Pete, can you share your screen now or just begin your?
Yeah, I think I can. Okay, can you see that slide?
Yes, looks good.
Okay, great. So yeah, thanks Todd, and thanks to the organisers for the opportunity to speak today. So this presentation is an overview of float deployment activities out of Australia and some of our science outputs so far. The Australian BGC Argo team is me and Tom Schall and Christina Schallenberg, with strategic advice from Philip and David, and we're funded by Australia's Integrated Marine Observing System. And we work closely with the core Argo team that's been in existence for a while. And our floats have been co-funded, many of them so far, by the Australian Antarctic Program Partnership and the Australian Research Council Special Gateway Antarctic Initiative, as well as capital funding from CSIRO. So this map with chlorophyll in the background shows our deployments so far. So prior to the start of our IMOS-funded BGC Argo program, CSIRO and UTAS deployed about 30 floats in the Indian Ocean and the Southern Ocean with varying sensor configurations. And starting in October 2019, we deployed 2 floats in the East Australian Current that was sponsored by SOCOM. And then from December last year onwards, we've been a bit more busy deploying 2 floats south of Tasmania on a voyage led by Philip Boyd. And these 2 floats had underwater vision profilers on them, which are basically cameras for looking at larger particles and zooplankton. Then 3 floats with all 6 parameters north of Prince Bay earlier this year. Those floats are now under the ice. 2 floats in the southern part of the East Australian Current in May this year, and most recently one in the Coral Sea. Next is one in the Eastern Indian Ocean, and then early next year there's a voyage to the Cape Darnley area northwest of Prince Bay, where we'll deploy at least 2 floats, and we're trying to work with partners to deploy more. So our floats have been about half and half manufactured by Teledyne Webb and NKE, and almost all of them except these 2 in 2019 have the full 6 sensor suite of parameters. And we continue to be very interested in working with international partners to use our presence in the area to try to get floats into the Southern Ocean and other areas near Australia. And that's the gist of this slide. So this shows potential deployment opportunities coming up in the next year or so. Some that we haven't allocated floats to, and some that could accept more. All of these voyages are on the RV Investigator, but Australia has a new icebreaker coming online in about 2023-24, and that could present opportunities as well. And then over the next year, we'll be working on refunding of our BGC Argo facility, as well as the core and deep Argo groups in Australia. So later this year, Investigator will be transiting the Great Australian Bight, then early next year going all the way down to Cape Darnley, as I said before, then to New Zealand, and then south of Tasmania to about 55 south. And it would be great if we could partner with others to use these voyages to contribute to strategic gap filling in the Southern Ocean region. Okay, so I just wanted to close by showing a few science highlights so far, and I'll be quick, so please feel free to get in touch for any further information or a PDF of these papers. First, we have a recent paper by UTAS who quantified the biological signature of Southern Ocean cyclonic and anticyclonic eddies. And I think the surprising result from this work is that the BGC Argo data don't reflect the simple view that we might have from satellites that cyclones are upwelling and high productivity and anticyclones are the opposite. Zhao Yang found positive anomalies of chlorophyll and backscatter in both types of eddies, depending on the time of year. And I think this highlights how much we have to understand still about Southern Ocean eddies. Next, we have a paper that I think is hopefully soon accepted, looking at the response of the South Pacific and the Southern Ocean to the Australian bushfires of 2019-20. And we observed from satellites a large bloom in the South Pacific, and the BGC Argo analysis for this work was spearheaded by UTAS PhD student Jake Weiss. And we saw very strong positive anomalies in chlorophyll and backscatter related to ion fertilization of this area by aerosols from those fires. Philip Boyd and Joanne Lord and I are collaborating with Leo Lacour, who's a Marie Curie fellow. And Leo is analysing data from some of our earlier BGC Argo deployments, and he's partitioning the particle export into the different types of particle export, these particle injection pumps that Philip has published on before, with a view to looking at their seasonal variability. And Leo gave a talk on this at the SOCOM workshop. Last year, we published similar work led by Seb Moreau, and Seb used BGC Argo to partition the grazing and export of marginal ice zone blooms and looked at a series of 9 floats in different regions around Antarctica. And as Christina showed yesterday, she's looking into fluorescence on BGC Argo floats as an indicator for ion limitation in Southern Ocean phytoplankton. In the future, we'll continue to focus on the Southern Ocean and Antarctica, and we're also pursuing research on East Australian current eddies with a proposal for ship time just submitted, and also other grants to look at the impact of marine heat waves on phytoplankton. Okay, thank you. With that, I'd like to close and I'd be happy to take any questions.
Thanks, Pete.
Quick comment on UVPs, Pete? Any update?
Do you want me to say something about the data? So Leo Lacour has been working on those data. Yeah, I don't have too much to say about them so far. They did some sort of calibration or cross-checking by putting UVPs on the CTD on that voyage as well, to try to compare the profile data from CTDs and water samples with what was coming from the float. So I think some of the issues around those instruments are that it's sort of a condensed version of the data that's sent back, and so you do need some ground truthing perhaps. So, but Leo's been working on those data quite hard, and I haven't seen a lot of results, but that's been his focus from that voyage. We're actually one more of our floats that we'll be deploying early next year has the UVP on it as well. And so that'll be going quite close to Antarctica.
Okay, well, we should, I think, move on to the next talk. I think, is Katya out there?
Yes, I don't seem to be able to share my screen. It's grayed out. Do you? Ah, there we go. All right, so I want to give a brief update on sort of Canadian BGC Argo activities and just to give you a little bit of the history. So Canada has been quite a committed contributor to the core Argo program since the early 2000s. And so there was quite a bit of sort of interest and enthusiasm for getting into BGC Argo as well. We had a workshop in 2017 in Halifax, sort of for planning, getting the community organized. And you can sort of see in this picture there the usual suspects from the Canadian Argo community. Ken was there too. Maybe you can pick him out. And we sort of, out of that workshop, wrote a vision and white paper sort of to lay out recommendations for Canadian engagement in the program. We have a website too that you can check out. So I'm going to first give a sort of very high level quick rundown of activities. And I'm going into a bit more detail on the latest. So Laval University, Marcel Babin, in collaboration with Hervé Claustre and so his French colleagues, have been quite active early on in terms of BGC Argo deployments and been pushing sort of the technology to go under ice. So there have been a number of floats deployed in Baffin Bay, which is ice covered in the winter. And so they have several seasons of under ice data. Then on the West Coast, University of Victoria has been adding oxygen sensors to a number of the core Argo floats that are put in the water by DFO, the sort of the government Department of Fisheries and Oceans in Canada. In the Pacific, then Ocean Networks Canada is a bit of a new player in the Canadian Argo community. They're basically responsible for the cabled observatories, but are interested in getting into Argo and BGC Argo as well. And they are planning to deploy 6 4-parameter floats in the Pacific. Then on the technology side, there's a project that was funded to support RBR, which is a sensor company, a Canadian sensor company, to work on, so they build CTDs. The CTDs are on some of the floats. You might be familiar with them in that context, but they're now working in collaboration with us at DAL and DFO to also develop prototype floats with sensors for oxygen and biooptics. So they have had oxygen sensors for quite a while. They're now working on also producing biooptical sensors. So that's ongoing. And then lastly, there's been a relatively big investment announced in BGC Argo floats recently. So that's a project that's led by myself in collaboration with a number of people across Canadian universities, including Memorial University. Utapaso is the co-lead of that project. And we're in the finalizing stages of securing funding for 42 BGC floats targeted on the North Atlantic. I'm just going to say a few more words about that. So we have planned 32 floats with the 6 sensor suite for the standard BGC Argo mission, and then set aside 10 floats with most likely a lighter sensor load for process-oriented sampling. So thinking here of floats to be deployed and recovered in connection with process cruises, sampling at a higher temporal resolution. So those type of applications. The grant also includes money for lab renovation and high performance computing infrastructure, because we do want to be able to sort of take those data all the way to the generation of products that are useful for stakeholders. And so science questions we're interested in, no surprises here. It's very much the same science questions many of you are thinking about too. But in this region, in particular, the Labrador Sea, right, we're quite interested in the sensitivity of carbon sequestration and ventilation to changes. of course, the rate of change in productivity and oxygen loss and acidification, and also assessing ocean and climate models in this region. It's a region that's notoriously challenging to models to get correct. It's also a really important region. So it's the global overturning and ventilation and carbon sequestration. So, you know, that's why we're sort of interested in those questions in particular. We're also focusing a bit on infrastructure development. So partly this is lingo to make the funding agency happy. They fund infrastructure only. So we're trying to develop approaches for rate measurements, so NCP, net community production, net community respiration, export, following these approaches that we've heard about in the last few days. We also want to develop algorithms for combining ocean color with the Argo observations for 3D products, and a data assimilative prediction system for the region for optimal hindcasts or reanalyses, nowcasts and products. And that's sort of something I just want to spend a little bit more, a few more words on the next slide. Before I go there, this graph sort of shows the projected increase in profiles, oxygen and nitrate in the region going forward. So the left panels here show what's been available historically from 1965 to 2019 in terms of profiles from bottle, CTD, and Argo measurements. And the right slim panels show you what we're sort of projecting going forward, assuming these previous sample collections go at the same rate. And the light blue is what this project hopefully will add. So we will get a big improvement in terms of information about the region. So last slide, just one quick example. I said we want to develop a data assimilative capability for this region. We have something like that set up in the Gulf of Mexico, actually. So there are two papers here, one still in discussion, talking about that, where we have an assimilative model set up. So the first study there at the top looked at optimizing the biogeochemical model using the limited BGC Argo data that's available in that region, and sort of showed how even limited a few, relatively small number of profiles can lead to a big improvement in this in the representation of subsurface fields. So we found that, for example, carbon export was much improved by using the profile information from the biooptics. And then the second paper there shows an assimilative model where we currently assimilating satellite observations and core Argo profiles, not BGC profiles, because there aren't enough for that type of exercise. But even the assimilation of the data in a model that was properly tuned by just a few BGC Argo profiles is already giving us a big improvement. Yeah, and so the graph there on the bottom shows the basically the shape of the loop current and loop current eddies in the region from satellite, which is the black line, from a free model run, which is the blue line. You can see that it's not quite matching what the satellite sees. It can't really if we don't put in the information in some form, right? Because it's a stochastic part of the variability, and a deterministic model has no way of knowing where exactly in which locations the eddies should be at which point in time. And by assimilating, we sort of correct for that, right? We can force the loop current to be in the right location, the eddies to be in the right location. And here on the right now, I'm going to show the impact on the subsurface chlorophyll distribution. So the top panel is basically what the float observed. So you see the chlorophyll evolution through time. The red line follows the deep chlorophyll maximum. The black line shows the sea surface elevation. And yeah, there are 5 floats that are included here in this graph. So that's why there are 5 panels. The row below, the panels below, show the simulated chlorophyll from the free run. So this is a model that's not constrained by observations. You can see that sort of on average, the vertical structure looks right. But so in particular, the middle panel shows you that the model doesn't have the eddy structure at the right time in the right place. And that's why the subsurface chlorophyll distribution doesn't agree well. Now the panel that just popped up below that shows the assimilative run where it's much improved. And so an important bit of information is that it's only improved because we previously tuned the model to properly represent the subsurface structure using the limited BGC Argo observations that we had available. And that's because, of course, the bottom panel shows the subsurface nitrate distribution because the information that's contained in the observations about the density structure in the subsurface, of course, then also means that we have information about what the nutricline is doing. And more details, of course, in these 2 publications there. And maybe I'll stop there and turn it back over to you, Todd.
Thanks, Katya. Really interesting. Are there any, maybe a quick question from the audience? I'm not sure if there's anything in the chat. I see Emily says, are these in the DAX? That really is a reminder of the importance. I mean, when I think about both what Pete and Katya said, that the importance of coordinating international float deployments and having some central databases where we can view all floats from the different programs and planning for future deployments.
Right. So these were deployed by the Bureau of Offshore Energy Management, I think is what the acronym stands for, BOEM. You can see it there at the top panel. So this is not data that we collected, but we got our hands on it. It's not in the GDAC, but they've been pretty generous in sharing it with anybody who asked.
Mm-hmm.
But absolutely agree with your point, Todd, yeah.
Well, I think to keep on track, and we can come back to this, we have some time for discussion later if there are more questions, but let's go ahead and move on to Hetty, who I think has a few words. Hetty's the chemical oceanography program manager at NSF.
Yeah, hi everybody. Thought I had changed my background, so let me see if I can do that again. And if it doesn't want to work, I'll stick with this virtual one. So as Todd said, my name's Hetty Edmonds. With the U.S. National Science Foundation. I'm a program officer with chemical oceanography. So my remarks here are a bit different than everybody else's. I didn't prepare any slides because they just would have been filled with text. So that didn't seem worth doing. I'm talking on behalf of a lot of my colleagues at NSF. Here because I've played a role on the science side of the house in both the review and now management of the GO-BGC Infrastructure Award. As Ken mentioned, the Infrastructure Award is just that, together with a subsequent award that covers the operation and maintenance of the floats. What NSF has committed to date is the acquisition and construction, the deployment, and operation of these 500 floats over the next several years. And that means that, say, unlike with the SOCOM program, no specific science has yet been funded. And now that you've all had these great tutorials this afternoon and seen all these really super interesting talks throughout the week on all the great things you can do with profiling float data, it's time to put your best ideas forward and get out there and use this resource as it continues to develop, recognizing there's already a lot of floats out there, as we've seen. I know a lot of the participants in the meeting are from outside the US. And so for you, I want to reiterate that all of the GO-BGC float data will be freely available. There are no national or other proprietary barriers to you accessing and utilizing those data. For NSF researchers or would-be NSF researchers, my basic message today is that the ocean sciences programs at NSF are open to proposals that utilize profiling float data to address interesting questions. The other point I'd like to make is that the funding of the GO-BGC array doesn't affect our ability or willingness to continue to support proposals that include targeted deployments of additional floats, as we've been doing for the last several years. If you have a specific science problem that you want to approach with a small number of floats in a given area, perhaps you want a specific configurable profiling interval or a specific set of sensors, we're still very much open to those. It's not like it's just, these 500 floats are the thing and that's it. We're also open to continued technology development proposals as well. So in summary, I think the funding of the array and all the growing international contributions open a lot of new doors for some really exciting science, and all the ones that have been open so far remain open. So keep the proposals coming. If anybody has an immediate question, that's great, or I can turn over to Emily Smith from NOAA.
Okay, I sang Baba Black Sheep in my head. Isn't that what you're supposed to do? So I'm going to share my screen. If I can do this correctly. It's always a challenge, right? Excellent. Okay. So following on to NSF, I want to talk a little bit about NOAA and what we've done with BGC to date and where we're planning to go in conjunction with the GO-BGC project. So for those who don't know, over the last 4 years, NOAA has invested $11 million in BGC Argo, including support of the SOCOM project, which is a multi-agency effort. And some of the things we've did, you heard yesterday from several folks talking about the pilot arrays that are being initiated in different US regions. Also looking at sensor data quality and improving sensors, the improved pH sensor, oxygen sensor, were all partially funded by NOAA. The biggest investment I would have to say that NOAA has made so far is people. At our two labs, in our Miami-based lab and our Seattle-based lab, you can see the plethora of folks that we have hired over the last 2 years, and really starting to bring out our expertise and also to build physical lab space in order to incorporate these floats. We have several academic partners through our cooperative institutes, and you've heard from some of those folks like Sarah Perkey and Rue Nicholson. We're also building up the US DAC so that all this data will continue to be free and available. We're partnering with MBARI to learn their real-time QC processes, and you can see the 3 bottom folks to the right are all dedicated to the DAC and processing BGC Argo data in real time and getting it out. Another really interesting project, there was a postdoc that was hired at our geophysical fluid dynamic laboratory in New Jersey, and she is looking at the physical and biogeochemical variability in the California current, and also comparing that to regional and global models to see if that variability is accurately represented. So that's another really strong suit of NOAA is our modeling team that we have. For our long-term vision, BGC Argo started as a collaboration with NSF as the lead and NOAA and NASA also partnering. We collaborate, you've heard from Lynn Talley about how we use GoShip to help deploy these floats. And I do not see that changing. I mean, it's going to be a collaboration going forward. And I think that's a good thing, right? We're pulling the strengths from the best of the best. If any of you dug into the FY22 budget, the president's budget, it's very encouraging for NOAA. It's very encouraging for Argo, specifically in the program I sit. So of course, we don't know if that will be finalized through Congress, but it's exciting to see an uptick in supporting ocean observing. And if those things do come into fruition, just like Hetty just announced, NOAA will be doing a competitive research opportunities in FY23 if budgets allow. So that's why I have my fingers crossed. Because it's one thing to get the data out there and make sure the data is accurate and high quality, but it's another thing to then use that data, right, and have really good applications for many different sectors of society. We also really would like to expand some of our ongoing education efforts. I enjoyed George's talk this morning about the Adopt a Float, and I know that Emily Osborne at our Miami lab is interested in doing something similar or just partnering to build on that effort with the NOAA floats. We also have a program called CREAD, a super long acronym, but what it is it's a partnership with some teachers in New Zealand who actually go out to the Pacific Islands and train teachers to then use Argo data, climate change lesson plans, sea level lesson plans in their classrooms so that the students get that real life interaction with ocean observing and how that affects their everyday life. And so it's a great program, and we would like to expand it to include BGC Argo as well. And you've heard all the success of Argo, right? Through this last few days, you've heard about technology, data quality, and having that open data access was the core, one of the core fundamentals of how the Argo system was started, and that every country that wanted to be part of Argo agreed to that, right? And that's how we've been so successful. And it's the people. The people in the Argo program are, I'm biased, but they're some of the best people I've ever worked with. And so because of them, Argo is successful. And I know that BGC clearly will continue in that tradition. And I will take any questions if you have them. And if not, can't see my
Emily,
sure.
Ken here. Are there plans to sustain and expand the California Current and Gulf of Mexico arrays?
Yes. Yes, NOAA will keep those going. Those are definitely in the plans. I think Emily Osborne, correct me if I'm wrong, but I think for the Gulf of Mexico, it's supposed to be about 15 BGC floats, and the California Current is 20-ish. Is that correct?
That is the aspiration. Ken, for next year, we have one float that we've ordered from Seabird.
Thank you.
All right. And it goes to, if I can find my agenda.
Yeah, thanks, Emily. I think that you're the last one. That CREAD program is cool. It kind of makes me think about our own need here to expand into the interior of our country. I was excited to see some of the states on Georgia's map, including my home state of Kansas, where they've actually reached it's about as landlocked as it gets. So let's see, we have some time left. I don't know if Ken was going to lead this discussion, but at this point on the agenda, we are at the meeting summary, open questions, final discussion point. So I think
we volunteered Ken to lead this section.
Yeah. Okay.
Oh, so somebody forgot to remind me of that, though.
Yeah, I mean, we could. One thing I was thinking about starting off with, Ken, was just are asking if there are any lingering questions from the breakout leaders or the tutorial leaders that they wanted to bring up at this point.
I don't think we had any lingering questions from the MATLAB tutorial. One good point was that this code, the repository links have been shared with the workshop participants, so we'll need to make sure to get that on the GO-BGC website so that everyone can find that later.
Excellent. And I would really like to commend again, all the people that worked and contributed code and so on. I was in the MATLAB workshop, and I really can see myself using that code a ton. It's really great. Thank you. It was, and I presume the other ones were just as successful. So awesome.
Yeah, I want to echo that as well. It was fantastic. Thank you so much for everyone who contributed to the code, and I hope that the community will benefit from it. And then, you know, this is all open source and open code. So in the kind of mantra, if people make any, you know, new additions or whatever, you know, share it with the community. That's kind of how we grow as a community. So I encourage that as well.
So to follow up on the comments, you know, what will make GO-BGC, SOCOM as well, but GO-BGC successful, and following up on Hetty Edmonds and Emily Smith's comments, you know, I really encourage users to start to plan and think about things they can do with the data. You know, there is a large amount of data out there now. So GO-BGC, we're just starting, first 11 floats in the water and sending data, and you know, even you know, international collaborations to analyze the data, you know, are really going to be key to the success of the program. The other you know, comment, and we've seen this at the Argo steering team meetings, but we need to really step up the international planning on deployments. So, you know, have made the point that GO-BGC doesn't have ship time, but other nations are stepping up. So and deploying floats as well. And so Katja's talk just now showing, you know, the Canadian plans in the Western Atlantic. We really, you know, will need to really start an active collaboration and planning with Canada in both the Atlantic, and I would expect as well, Katja, in the Pacific too, to some extent. I mean, you've spoken about the oxygen floats that are now operating in the Pacific, and you know, I think to get the 1,000 floats evenly distributed that we wish, you know, we all have to interact in a significant way.
Yeah, I agree. And I mean, we can sort of look at Core Argo, who are doing that quite successfully, and sort of learn some lessons without making the mistakes first that maybe they made, if they made any, I don't know, but yeah.
Yeah. Absolutely. So, you know, that's the challenge really to build this array. It's going to take significant international collaboration. Lynn showed the Go ship lines, which only get, you know, occupied once every 10 years, but you know, many of them once every 10 years. Getting floats spread globally is going to be a bit of work. Emily, you popped up, and I expect you might have something to say. Is that?
Yes, Mike Patterson asked a question in the window, and I started to type out an answer and felt it would probably just be easier to say. So he was asking about, you know, looking long term, is NOAA going to plan to sustain BGC Argo beyond the NSF project support? And so something that folks outside of agencies might not understand is right now we are planning for FY24 budget. So federal agencies plan 3 years in advance, meaning this next spring, in a year from now, we will be planning the FY25 budget. And we would need clarity from NSF of what their intention is before we made any type of request, large request like that to take this on, because it would be very hard to sell if a NOAA says we're going to take this on and then NSF says we're going to keep going. So that's something we've got to sort out. It's not beyond the scope of possibility, but we've got to figure that out first.
Yeah, totally agree on the point that federal, this is a interagency discussion that is above my pay grade. Yes. Anyway, back to the challenge of getting floats in the water. There are going to be challenges associated with ramping up production as well. And so I think that we need to work closely with our industrial partners in all of this. And Katja, you spoke to the role that Canadian companies, for example, and I think there were European colleagues that I'm not looking at the participants, but I know that the EU is also very active in looking at sensor development and so on. But I expect to see new sensors arriving on the horizon. The UVP profiler is a nice example. Lots of interest in expanding radiometer capability from 4 wavelengths to the hyperspectral region, and I know that there are floats in the water in the EU that are testing that capability now. So I think that we will expect to see that the parameters will evolve, and they have already evolved. I mentioned earlier that oxygen has gone from a Clark electrode that worked well when it worked, but didn't always work, and evolved into the optical oxygen sensor. And I think that we will continue to see sensors in the system improve their capabilities. I mean, that we're just early on in the really significant ramping up of the program. So gosh, I'm neglectful in my comments. Otherwise, I would be glad. Let's see, I should look at the chat. Somebody is asking, is there any good global merged gridded reanalysis product of data from satellites and subsurface from Argo? At the G7 workshop, which was last month, this came up as a similar topic. Building merged data sets, and point I made in my talk that there's a huge synergy between our BGC Argo satellite observations and ship-based data. And I think it is a challenge now to the community to start to put together a data set that really merges all of those products and looks at the various parameters that are observed in the different programs and finds a way to make them numerically compatible. The example being chlorophyll. So we need to be sure that chlorophyll from a float is compatible with chlorophyll from a satellite, and the HPLC chlorophyll from a ship. And ultimately, then taking all of those data sets and gridding them, I mean, is going to be a huge service to the numerical modeling community. They have a desire for gridded products, a huge service to the fisheries community. So it was very apparent in the food web discussion and in fisheries, the Kara Wilson's talk on fisheries. I think that right now we have a hard time getting above, in the ecosystem, getting much beyond chlorophyll with the current sensors that we have right now. But what BGC Argo can do, and can do very nicely, is map the environment and really understand parameters like oxygen that control the distribution of pelagic fish like tuna and really start to understand, how the species, understand the basic environment that species operate in. So I think that, merge gridded products have a huge future. I know that in the SOCOM program, there are a number of people looking at ways to do that. And I don't know if anybody wants to speak to that. But that, there's a big opportunity there. There's an awful lot of oxygen data now from BGC Argo all around the world. Well over half of that data has now gone through very serious quality control and adjustment and is ready for scientific applications. And, really one of the first, things to be done with that is to create products, oxygen distributions, mapping OMZs as an example, remapping OMZs with what had been fairly sparse chipboard data to, really start to look at change. So a large number of floats in the Arabian Sea and Bay of Bengal, and there have been a number of floats in the Eastern Tropical North Pacific, and using those to look at OMZs would be a huge, it'd be a big undertaking, but I think it'd be a huge service to the community. If we could really, look back at that. Katja showed a slide which shows the number of oxygen profiles. I think, Katja, yours was North Atlantic, but it's true globally that profiling floats now dominate the availability of high quality oxygen profiles. And I think that we can really start to look back at ocean deoxygenation and just really update the distribution of oxygen and OMZs and shallow oxygen maxima and so on in the ocean. At this point, I would be glad to entertain any more. I'm looking back at the questions. Gridded products. Question for Emily, long-term sustaining. Who is working on hyperspectral inclusion in the EU? Eric, that's a question from Eric Rehm, and I can tell you that Argo Germany has a number of floats with hyperspectral. Name is escaping me right now, but Henry Bittig is involved in that, so Henry would direct you to that. One issue brought up by the Float Tech Breakout was a desire for additional funding for sensor improvement. That's from Eric, and so I totally agree. And I'm proud to say that much of the sensor development in the U.S. has been done at the Monterey Bay Aquarium Research Institute, and we've been successful and able to sustain that because we've had long-term support from the David and Lucille Packard Foundation. But I think there needs to be an avenue like that for the rest of the community, longer-term sustained support. You just, hard to go from the initial proposal, which kind of funds a concept, NSF style proposals, fund the concept, to making a really hardened sensor that can be deployed on floats. That funding for the next transition doesn't really exist in the US. There is in industrial development, that's known as the Valley of Death. There's a lot of money for development. There's a lot of money to incorporate things in operational systems, perhaps, but there is nothing to transition them from development to operation. Oh, it already actually says that. Eric's got it right there, the Valley of Death. Yes. So Emily is responding, sees that as a priority. And Emily, I don't know if you want to say anything about that.
I mean, I can. It's, I've already help fund the thermometer improvements, the pH sensor, the oxygen sensor at UW. So it is a priority. I can plan to continue to do that. I know Hetty also commented that NSF will also continue to do that. I'm sure she's like me. It's as we have funds, and it's as this community raises the issues. You know, as much as I know, I'm a big picture person. I'm not down in the technical details of when a sensor is not, you know, putting out the output we expect. So it's up to the community to also help us know when we need to fund these types of projects.
Yeah, absolutely. And to some extent, it's Emily, meetings like this where the community can provide input on, you know, the need to move to, you know, multi-wavelength fluorescence or hyperspectral radiometry, things like that. But definitely, I think Argo needs, you know, BGC Argo, you know, we need to always be refreshing our technology as we've done with oxygen. We're not, you know, when you build an operational array, you don't do it with experimental sensors, but as new technology becomes available and is developed in the community, we need to be aware of that, and as appropriate, you know, move it into the array, which you know, is to keep us, you know, at the forefront of operational observing. Good question from Andrea. As the array grows, how can we reduce redundancy in tool and data product development between groups? How did Argo do this, or is redundancy ideal to find the best option? And, you know, I don't know whether we should have Steve Reiser answer that question, or Susan Wafels if Susan is on. But I think that Argo has had equivalent redundancy. If you go to the Argo website and look at the variety of products that are available for things like mixed layer depth or ocean heat content, there are, you know, always, you know, multiple groups doing that, and it is much like the, you know, the temperature records in the earth. There are always different groups doing it with different technologies, and so they're having a bit of competition, I think is good.
I think this is Steve. I think Andrea's right, though, that if you look back at Argo, there in the beginning, in the first several years, there were lots and lots of these, and they many of them converged on a winner that was the best one and was the most the one that was used by the most people. And some of those winners are still out there after 15 or 20 years, and they're still being updated all the time. I like the idea of having lots of different groups do this and see what comes out of it.
Mm-hmm. Yeah. I mean, that's sort of the element that is the, you know, the competitive, I guess, you know, entrepreneurial way, and because whether you're gridding the data, so there's a comment from Alison, by the way, on gridding data. Efforts underway to create gridded products at the UW, at Scripps, and it was interesting. We had at the SOCOM annual meeting a few weeks ago, we had within the SOCOM project itself, were there 4 different talks on different ways to, and quite different ways to create gridded BGC products in the ocean, using the data to really improve mapped products. So, you know, kind of like we would create a weather reanalyses. So you take the model, you take the data, you find out why the model doesn't fit the data, you fix the model and really use the model to create the high resolution data, but it's really driven by the data versus other technologies to you know, not objectively different, some well beyond objective analysis ways. I don't know, Alison, if you're on, if you want to speak to that briefly, but there are, you know, lots of ways to map data. Not hearing from Alison, Steve, and I know Steve as well is looking at under ice maps and yeah, so it's and Somebody made the point yesterday about the in the discussions about the very high correlation between physical variables and biogeochemical variables, often on small scales, and using all of the high resolution Argo data combined with BGC to produce improved mapping products. So that definitely is happening, and people are going forward doing that. I'm looking at the questions. We need, let's see, so great question. That was Allison's reply. We need more research to develop the best techniques, so redundancy is ideal. Thank you. I'm pondering the questions here. Let's see. And as Allison says, collaboration is good to avoid repeating the same things. That is absolutely true. Answer from Hendrik Bugener that it's the ICBM Institute for Coastal, I don't know, anyway, the University of Oldenburg are working on hyperspectral radiometers on floats using the Trios Ramses sensor. But the comments are coming faster than I can read them. Lynn Talley is saying redundancy in products is important, different approaches and caveats, and there okay, good. I'm going to write this one down, Lynn. You can't have a winner until there are multiple entries. We will archive that. What is the max depth for BGC Argo floats, and do deep Argo floats include BGC sensors? So BGC Argo floats 2 kilometers, 2,000 meters is more or less the maximum depth. There is, interestingly, a big push for deep Argo to put oxygen on the deep Argo array. I know that Virginie Terry, Ifremer, one of the lead scientists in developing deep Argo, has put oxygen on many of the Ifremer deep floats, and really, from a physical oceanographic perspective, as a water mass tracer, they've made the argument that every deep Argo float should have oxygen on it. In particular, when the oxygen floats, if we can do an air oxygen calibration, if the oxygen sensor is placed so that you get an air value in the float surfaces, you'll get a really valuable record of oxygen throughout the ocean, all the way to the seafloor. And in principle, there should be a large gradient. It should be a small gradient in oxygen near the seafloor due to oxygen consumption in the sediments as well. And really interesting science could be done with oxygen gradients near the bottom, understanding sediment oxygen consumption and carbon flux to the sediments. Will be harder to do for other sensors like nitrate and pH. We assume that the deep ocean is our stable reference. We need continual updating of that stable reference from GO-ship type observations, but our sensors are not as perfect. Argo itself, they adjust their oxygen, their salinity sensors in the midwater, assuming that's a relatively constant reference. And it's a challenge for them now developing salinity sensors that are stable enough for the lifetime of the float that they don't need a mid-ocean reference. But right now, as pointed out in Yui Takashida's talk and Tanya Mauer's talk, we assume that we can make mapped fields at 2,000 meters and use that as a reference for sensor drift. So going deeper with like pH and nitrate will be hard. Particle sensors, though, optical backscatter sensors to the bottom might also be another option. See, how can we involve nations that don't deploy floats and would benefit from using the array? So in a national level. So first of all, I think that engaging, nations internationally, training people to use data. So the C-READ program came up as an example of international communication. But I think that we need to really, essentially have, this workshop we had 25 nations involved in this workshop. But we need to be very active in encouraging nations that all around the world to appreciate and use the data. 40% of the world ocean is somebody's EEZ, and we need people in those nations to appreciate the data that is going, that we hope to be collected in their EEZs by floats transiting through. The ocean change, doesn't respect borders, so acidification, warming, changing nutrient fluxes, changing fisheries will affect all nations, and just having more data will help understand that. And having the various nations, the scientists, the communities understand what the data is about, how to use it, is really something that we need to make sure. So I was very pleased to see the broad range of nations using this attending this workshop, and I think that we need to keep working in to encourage all nations to understand and value the data. I think the data access workshops were great in that regard. Let's see, scrolling back down through the questions. So Mike Patterson is in front of my last comment. Are there challenges in data sharing from BGC measurements within country EEZs? And if yes, what strategies for addressing them to meet open data sharing goals? So Argo, so every nation has territorial rights to regulate what happens in their EEZs. Argo operates under a UN agreement from that floats in EEZs may collect data. The nations still have a right to disallow. So the international agreement is unlike a research cruise where you may take a year getting clearance for your ship to enter another nation's water and sample. Argo profiling floats are automatically notified to nations. So the process is automated, and a nation can still ask that when a float enters their EEZ that the data be turned off. That just doesn't happen. And that was true for the core Argo variables. And a year and a half ago, that permission was through a really great effort by the Argo steering team led by Breck Owens. That and IOC in particular, Albert Fisher, that permission for a somewhat automated submission of clearances was extended to BGC Argo. And so when a BGC Argo float enters another nation's EEZ, the nation is automatically notified. And so you don't...
Well, I'm gonna jump in, Ken, for a second.
Thank you, Emily.
So when floats drift into EEZs, not deployed, but drift into EEZs, they continue to transmit data. There are 12 countries that have requested they get notified when this happens. And that goes to the country who deployed the float. So in the US, I get those emails every Friday, and I then notify the proper country of where the float is drifting into their EEZ. To date, only one country has ever requested to have Argo stop transmitting their data when they're in their EEZ. Everyone else is fine with you transmitting it. They just want to know, those 12 countries just want to know when a float's coming into their waters.
Yeah. And so that was true for core Argo, and that agreement has now been extended to BGC Argo. So again, so that was a huge lift. The Argo steering team, really, I mean, to support us, made that happen. Breck Owens led that charge and, presented to the IOC, and it was approved unanimously. by the IOC nations. So as Emily says, you have to have explicit clearance, may take you a year in advance, whatever, to deploy a float in a nation's EEZ. But when they drift in, it's automatic notification. A nation still has the right to have us turn off the sensors, but it's rare to have that happen. And one of the reasons this comes back to the, our need to educate and inform and really train people to use the data everywhere to make sure that, the program, people support the program and that they see the value of this data for their nation. So those two comments kind of go together. And thank you. So I'm down to the end of the questions here. Going back to see if I skipped any other. We are coming up to our 1:15 time, but any other questions? If not, I want to thank everyone who participated in the workshop and made it happen. OCB in particular and US CLIVAR for their support in making the workshop happen. The National Science Foundation and as well as NOAA and NASA in terms of funding support for US BGC Argo that's gotten us to this point. Has been really appreciated and I think really forward looking by the agencies to support this. And Steve Reiser and his colleagues that organized the workshop and all of the speakers that did a great job and all of the participants in the workshop. A little bit of technical difficulty there, but I think that I attended the MATLAB one, and I am just totally blown away by the coding that I now have available to me. So this is really great. Any last words, Steve? Would you like to say anything at the end as we go? This was really your effort. Steve wrote the proposal that funded this.
Well, I'd like to thank all the participants. When we started, we thought, well, maybe 100, 150. We had well over 300 registered. I don't know if we had that many people actually log on at any given time, but it's great to see this global interest in BGC Argo and in GO-BGC, and it's when you think of where Argo was 20 years ago and where it is now, and you look at GO-BGC where it is now and where it will be in 5 or 10 years or 20 years, it's very there's nothing but optimism there about what we're going to learn about the ocean from all of this.
I think this will really, as Argo has done for, transforming our understanding of, a variety of things well beyond the original vision of Argo, which was, really something about ocean heat content. And it's everything from mixing to circulation to the overturning circulation. BGC Argo, I know what we're building it to do, but what it will be used for is, really, I don't think any of us really fully appreciate that. And so it's going to be really exciting. Somebody said at the SOCOM workshop a few weeks ago that a great time for early career scientists. It's a huge opportunity. And if I will, as my last statement, write proposals to NSF, to NOAA, and make it clear that you're using the data, because that is what will keep this going. Thank you all, and we're 6 minutes early. Anything else from anyone? If not, thank you all. Okay.
Once a co-host logs off, it's over, I guess.
Yeah, just don't end the meeting. You can leave the meeting, but don't end the meeting.
Well, my choice is end or leave the meeting. And
So you could leave.
You can leave.
thank you, George.
Or
Please don't save the chat.
Mariah could take co-host abilities away from you.
I had a question. I don't know. I guess this is for the organizing committee, but did we ever come up with like a way to solicit feedback for what worked, what didn't, and things like that?
We do have a mailing list for everyone that registered.
Mm-hmm.
Suppose we could send out a mass email.
Yeah, that might be, yeah, because we have to do this again in 2 years or something like that. So it might be good
I
to.
don't know if Heather is still on, but OCB generally sends out a questionnaire at the end of these kind of things. Heather
Yeah.
or
Heather just put that in the chat. Yeah.
Yep, and if you guys have a list of questions you'd like, I can put together a form survey that we can then send out, and just like the registration, you'll be able to see all the details in the back end.
Oh, great. Okay, that's wonderful.
Sure.
Maybe, yeah, we'll come up with maybe a couple questions.
That sounds great.
Yeah, I guess one question would be do we want to do it virtual again in 2023, or do we want to have a smaller in-person workshop?
Be a good question to put on the survey. We might be meeting everyone from all over.
Yeah.
I think by 2023, we'll probably need to do hybrid. I think a lot of people are sort of expecting, even if you have an in-person meeting, that you know, broaden participation through remote. So
I think it's great that we had so many people participating from so many places.
Yeah, agreed.
And for graduate students or early career people who don't have, who can't travel that easily, virtual is really ideal.
Yeah, it'd be unlikely, I think we had 160 at one point, and I think if you do it in person, you'll get at most 50 people.
Yeah.
Something like that.
Or you get more local people, but not the international.
Yeah.
And especially, for, the international participants,
Maybe we make it so that the international people come in person. If we could provide some travel funding, and all the local people who are in the right time zone can do it virtually.
Well, question
Yeah,
we
time
will
to
know
think about this.
in a year, we'll know. George, you'll face this problem
next year.
Well, next year the teacher workshop is going to be in person. We talked about trying to do it virtually the last 2 years, and we decided not to do it. It just doesn't lend itself well to a virtual format. Teachers spend enough time in virtual meetings. The last thing they want to do is spend 4.5 days in a virtual workshop.
That maybe do you typically record it or any parts?
We haven't, but maybe we will. I think that's a great idea. For those people who can't make it, we could certainly record it.
Yeah, maybe not the whole 4 days, but
no, but certainly the presentations by the researchers. We usually post the slides, but we don't post video.
Yeah, that might be nice.
Yeah, that's a great idea.
Okay, well, I'm going to go decompress. Actually,
have a great vacation, Ken.
I'm going to go. The vacation is Friday. I have to go finish the SOCOM annual report, I think, for Roberta.
Yes, you do. And we have a project office call tomorrow for those who will be available.
At 9.
9, yes.
9, okay. The call came up. I got a call at 8.
The External Advisory Committee.
Yes, in the afternoon.
I've got to work on that next meeting.
All right. I'll be at the car dealer in the afternoon, so I'll just be listening in. But
Cool.
you don't have me scheduled to talk anyway.
No.
So
Hey, Ken, since you're still on, I figure you want to see these are your first GO-BGC floats that you guys just sent us. They're
Hey,
they're getting ready to go out on the deck this weekend.
oh, nice.
Very
Very good, Rick.
cool.
Thank you.
Yeah, so we'll have them out there, and hopefully by next week.
Well, so this kind of answers. Lynn had asked a question in an email this week, which I barely touched the email this week, but whether, if there are issues with the floats we planned for, like for the rising cruise, whether we would have Apex available.
Yeah, I talked to Dana and Steve about that this week, and you guys are going to have to make that decision if you take it off of. They may be available. They're not fully tested yet, but they will be tested in a little bit.
Yeah.
The issue is that these are all ballasted at 1,500 meters for that specific ocean. I think it was this is going on the Brown out of Miami.
Yeah.
So that's how they've been ballasted. So if you take them from here, you got to put them back somewhere.
Mm-hmm.